Hello everybody! Today we're going to take a look at a use for factoring. So why are we doing all of this factoring business anyway? Because we're eventually going to need this skill to allow us to solve. So today our focus is how do I solve by factoring? So today you're going to need some regular notes in your notebook. Okay, so your regular composition notebook, and a pencil obviously, or a pen is pretty necessary, and a calculator is always helpful. So here's the prior knowledge that we've been talking about. Don't need to write this part down. We have these 4 ways to factor: greatest common factor, grouping, AC method, difference of squares. Those are all the things that are in your foldable. GCF is what we look at first, always. Okay, greatest common factor works no matter how many terms the expression has. Sometimes this is how we get it started so that it gets to have smaller values or smaller numbers. Sometimes this is the way we work with those. Then we're going to decide what method to use based on how the expression looks, so the number of terms that it has. You already know how to factor, but now how do we use it to solve? Also known as how do we use it to find x or figure out what x is. So this is your first example. Go ahead and write this one in your notes. You see x squared plus 9x plus 14 equal sign 0. The idea of equal 0 is new to us now. Before there was just x squared plus 9x plus 14. Now the equal sign 0 after it tells us that we're supposed to solve. There's an equals, there's an equation here, not just an expression. So what we want to do is factor it first. You see my little notes here. First, go ahead and factor. We're going to take a look at this guy right here all the way up to the equal sign. He has 3 terms. Is there a greatest common factor that a person could divide out of all 3 terms? Can I divide an x out? Can I divide them all by 2? Can I divide a 3? No, you can't divide anything out of an x squared, a 9, and a 14 other than 1, and 1's not going to change the expression or equation at all. So once I establish that greatest common factor doesn't exist for all of these things, then I go ahead and I factor using another method. Because this has 3 terms, x squared plus 9x plus 14, I'm going to go ahead and use the AC method. So this is a 3-term. I'm going to use the AC method. The AC method again was take the a, which is in front of the x squared, that number, times the c. So 1 times 14. That's 14. I need to try to figure out what numbers multiply to make 14. Well, obviously, there's 1 and 14, there's 2 and 7. We're looking for the pair that will add to make 9. Well, 2 and 7 add to make 9. So then I'm going to rewrite this problem, x squared plus 2x plus 7x. The 2 and the 7 come from our list. They still make 9, but it's a different way of writing 9x. So that I have 4 terms. My goal is to turn a 3-term problem into a 4-term problem so that I can go ahead and fill them into the 4 squares. So the x squared, the 2x, the 7x, and the 14 will all go ahead and fill in here, and then take a greatest common factor, divide something out of every row and column. What divides out of an x squared and a 2x? An x. What can divide out of a 7x and a 14? A 7. X squared and 7x? An x. 2x and 14? A 2. So my factors are x plus 2, x plus 7. Now remember, this was an equation, so this had equals 0 after it. Once I have him factored, then you see my second step down here says set each factor equal to 0 and solve. So I'm going to take the x plus 2, set it equal to a 0, and the x plus 7 gets set equal to 0, and you go ahead and you solve those for x. You're going to get 2 answers. If I do x plus 2 equals 0, subtract 2, x is negative 2. Minus 7 here, x equals negative 7. You get 2 solutions for x. So this was an x squared problem, and I ended up with 2 solutions. Coincidence? Nope, I think not. Anytime you have an x squared, you will be looking for 2 solutions. Our 2 solutions are negative 2 and negative 7. So thinking about that, why did we set these 2 things equal to 0? You don't need to write this part down yet, but kind of pay attention to this whole idea. Why are we setting each factor equal to 0? Well, let's pretend. What if Kincaid says, I'm thinking of two numbers, they multiply to make 0. My first number is 7. What's my second number? So in your head, you're thinking, okay, Kincaid's thinking of two numbers that equal 0. The first one's 7. What has to go right here in order to make it multiply to make 0? Well, it has to be a 0. The only time you can multiply to make 0 is if one of the numbers was 0. Or even both of them could have been 0 if I hadn't told you the first one was 7. So this is the idea of the zero product property. When two things multiply to make 0, two numbers, two expressions like we're talking about here in factoring, one or both must be 0. So remember back on that last problem, that's why we set it equal to 0. That last problem we said, hey, x plus 2 and x plus 7 are multiplying to make 0. That means either this one is 0 or this one is 0 or they're both 0. So that's why we take them when we set them equal to 0 and solve. Okay, let's look back at our second example here. Let me fast forward past all of our work. Here's our second example. Go ahead and write this one down. We are going to factor and solve again. This time taking a look again at my terms, I have a 4x squared plus 22x plus 10. So again, this is a 3-term problem or expression on that side of the equal sign. This is an equation that we're going to solve. As I look through all of those numbers there, I'm noticing that they're all even numbers. So this is communicating to me that maybe I should think about a greatest common factor. Is there a number or letter or variable that I can divide out of all of those terms? Yeah, 4, 22, and 10 can all be divided evenly by the number 2. So I'm going to go ahead and write that 2 out here and then divide that problem every single piece by 2. So this becomes 2x squared, 11x, and 5. That 2 is the greatest common factor that has changed our problem now to be this guy, 2x squared plus 11x plus 5. I still need to factor some more. This is still a 3-term problem that I need to break apart some more. So I'm going to use the AC method now after I've taken out the greatest common factor. So 2 times the 5 makes 10. What multiplies to make 10 and adds to make 11? 10 and 1 do. 10 and 1 multiply to make 10 and add to make the 11 that's in the middle. So we're going to go ahead and rewrite the problem. 2x squared plus 10x plus 1x plus 5. And you might be thinking, well, what about that 2 we took out right away? Just kind of let them be there. It's fine. We're just going to deal with our factoring of the 2x squared, the 11x, and the 5 for now. He's still out here. He's just hanging out for a while. So we're going to go ahead now and place all of those in the boxes and factor out 2x, 1. This way I can take out an x. I can divide out a 5. And then I'm going to go ahead and write my factors. 2x plus 1, x plus 5. And remember the 2 that we divided out initially? He's still in front here as well. And all of this is still equal to my 0. That was an equation that we started with. And remember, the zero product property says, go ahead and set each factor now equal to 0. So x plus 5 equals 0. If I solve this, I get a solution of -5. 2x plus 1 equals 0. I'm going to subtract the 1. I'm going to divide by a 2. X is -1/2. And now here we come to that 2 we factored out initially. That 2, if I set him equal to 0, that doesn't make any sense. There's not even x's there for me to solve. Like, I have no x's to get alone. That 2 does not lead us to a solution. That 2 is a part of our factoring that allowed us to break it apart a little bit easier. So our 2 solutions are -1/2 and -5. Let's take a look at a third example. This one looks a little different because we don't have that equals 0 thing happening. And we don't have everybody together on one side. So that's a little strange. So let's go ahead and think about how we would do that, how we would bring them together here on one side and try to figure out what my solution is going to be. So if I take a look at, well, I see 9x minus 8x. Well, that's like an x. On this side, I have x equals x squared. I'd like to get everybody together on one side here, and so I have an equals 0 happening. I'm going to keep my x squared where he is, and I'm going to subtract that random x over to the other side. So I get 0 equals x squared minus x. Okay, now I have my 0 there in place, and I take a look now at factoring this piece right here, x squared minus x. So if I look at that and I try to figure out what can I do, I again look always at greatest common factor first. Greatest common factor, is there something I can divide out of both of those terms? The answer is yes. I can take an x out, or I can divide an x out of both of those terms. If I divide an x out of an x squared, he's still an x. Subtract sign. X divided by the x that I took out is just 1. So I have factored him now so that I see an x times an x minus 1. And again, I'll set each part equal to 0. So x minus 1 equals 0. Add the 1 over. X is a positive 1. This little x out in front, if I set him equal to 0, well, I don't have to do anything. The x is already alone. X equals 0 is my other solution. So again, I'm getting two solutions because the degree, or the highest power here in my equation, was an x squared. That's something we're going to kind of tie together later in the year, but that's a clue that we should be looking for two solutions, okay? Those are your three examples. We'll do some work on this on Monday when you come to class. Thanks.